Welcome you all for the fifth session on NumPy. We will see some more examples and clear all the doubts in case if you have on broadcasting, which is a very important feature of NumPy, which you should all of you know. I will show you a few examples as well as explain you exact the definition and then why is it doing the way it is, okay, so that you understand the background of what is happening. And then we will also look at index. So I was talking about having a n-dimensional array and then we want to perform some operation between them. Now when I say n dimensions, for each of the dimensions we mention some numbers. Let me say 2, 3, 5. And then I have another array maybe of again same 3 dimensions are there, but the size is maybe 3, 5, 2. Now there are some basic definitions of the ND array in NP. So we are talking about the n-dimensional array in NumPy. Now what is the size of the array? First, size. Size means the total number of elements in the array. So if each of the dimensions having this many elements 2, 3, 5, then the total size will be 2 into 3 into 5. Okay, this is the total size, which is 30. Now what about this? Its size also same, because if you multiply this also you will get 60. But can we perform an operation between them? Just because the sizes are same, that doesn't mean that we can perform some operation. What I mean by operation, it could be some multiplication, division or addition, the basic operations. If you want to do this, we mean to say this operation is performed on every element of, you pick every element of this and then pick the equivalent corresponding element of this and perform this operation and find the new dimension in n-dimensional array. We will perform the same operation on every element by element we perform it. But can we do an operation between a dimension of 2, 3, 5 and 3, 5, 2? Are they same? Is there any problem in doing it? That is what is captured by the broadcasting feature of NP or NumPy. So we will try to understand that. Now when I say dimensions, this 2, 3, 5 means 2 rows, 3 column of again 5 elements, 5 such set. Okay, 2 I have already explained it. So maybe 2 rows, 3 columns. That element is 5 times. If you repeat it, then you have this array. Okay, so as you go from this direction, we keep adding that many copies of what you see on the left. So if you see a 2 by 3 array, a 2 rows and 3 column, 5 times if you repeat, you get the 2, 3, 5. If I add one more dimension 6, suppose if I add one more dimension 6 here, I am repeating the whole thing 6 times, then I get a next dimension value. Okay, that is what I mean by having multiple dimensions. Okay, now before I go into broadcasting means the same value is taken and sent across to multiple elements to perform the job. Okay, now let us first try to understand if I need to perform this job. Look at this. I have this is only one element, this is 2 elements are there, and this 3 dimensions are there. When I say comma 3 dimensional array, this array is created, which is A, and then there is a scalar element B. Now I want to perform A into B. Then what is done is this element 2 is multiplied with all the elements. How many elements are there in this? 1 into 2 into 3. So 6 elements are there. This 2 will be multiplied with all the 6 elements and you get it. Now I mixed it up. When I say list of element, I am giving actual values. Okay, it's not the dimensions, it's actual values of 1, 2, 3. It's a single dimensional array with 3 elements. Okay, now I will tell you what is the difference. Now this confusion might happen, whether are we mentioning a dimension or actual element. there is a subtle difference between that. I will talk about it when we are giving a element or this. There is a subtle details. Now let me correct it little bit here. Okay, this is wrong. Okay, I will correct it. I will tell you why it is wrong shortly. Okay, please hold on. I made this mistake. Okay, now let me tell you again. I am saying I am creating a NumPy array filled with ones of this. Let me give you, in this case, if it is okay, I'm showing the result like this, so I should not be ones, I should not put. Okay, this is correct only, but I will tell you why I am writing this and what is the difference between. If I write ones here and array, there is a difference. I will just hold on. I will clarify that in the example. Right now I am creating a single dimension array with only 3 elements, and then I am multiplying it by 2. Okay, that's all. Okay, fine. Now a scalar b being stretched. Now we are actually stretching that value to make it equal to this number of elements in this array, one dimensional array, and then we are multiplying it by 2, all the elements. That's what we are doing. The stretching analogy is only conceptual. We are, when we say we are stretching, this 2 is actually considered to be another one single dimensional array with a 2.0, 2.0, 2.0. Okay, and then we multiply individual elements. We want to make this as a single same shape or a same number of elements, and then we want to multiply by element. So we get this result. That is when you are creating with an array. Okay. Now this stretching is conceptual. That means we are really not doing a stretching while computing these values. Now what I mean by that, let me explain. NumPy is smart enough to use original scalar value without actually making copies. So it doesn't make multiple copies to perform this job. It knows internally that, okay, you are trying to multiply one scalar value with all the elements, so it will only keep one value. Now I already explained this. CPU is here, memory is here, and you have these values 1, 2, 3, and then you have only one we want to multiply with all. So it will not stretch it to make it 3 copies, and then it will not bring one by one these 3 copies into CPU to perform the job, because it involves memory read and it involves more size in the memory also. So it affects the performance as well as the size of the array. So it will only keep only one value and then multiply it with all the elements. That's why we are having a performance increase when you do a stretching of a single scalar value. Okay, compared to actually having an array of the same value in multiple places. Okay, this I already explained in the last class also. So in fact, the code here with a scalar value in B is more efficient than performing the same operation with an array of same size. So performing a same operation with an array of same like this is less efficient compared to just performing this 2 with this. Okay, so that's why NumPy is better, because the broadcasting feature makes it better, because it doesn't make multiple copies, it doesn't access it from the memory multiple times. Okay, this is clear. Now let me, as I promised, I will show you the difference between what I meant so that any confusion is there will be resolved. Now let me take an example. Okay, now one thing I want to mention it here. Broadcasting and indexing we are going to print. Now I want to explain something about the buffer size in the console output. This is the console. It is outputting some characters. How many lines it can output, we can configure it. Now suppose if you are printing many number of lines, suppose a big array you are constructed and then you are trying to print, if the buffer size is not sufficient enough, you will not get all the output here. Now what I mean by that is, suppose console is having, okay, there's some size, okay, how many lines it can print, that is a buffer line size. Okay, now suppose if it is set to some 500, if your program is running Python file and then it is outputting it, if it is outputting 1000 lines, what happens is this 500 lines will be printed and then it will be like a cyclic buffer. So since you have set this limit to only 500, only the last 500 lines of your output you can see on the screen. The first 500 lines will be overwritten. Okay, you can only see this much here. So sometimes if you are printing some huge array in your Python program, you might see that some output is missing on the on a console. So if you are using this or any other IDE, the same behavior you'll be seeing. So go to preferences and then console. There is a number of lines there. Okay, I increased it because I noticed the same issue which you may also come across and you may get confused. So I thought I will bring it up here. If you mention a large array, then you can have that many lines will be printed, then only it will overwrite on the output. Okay, so you understand this, so that you, in case if you get into this kind of trouble, you will remember it. Okay, fine. Now I am going to explain something which I told you about some time back. Okay, now one by one we will see. I want to only show some examples right now. Now a range is similar to range function that we have. This is inclusive and this is -1, so you know that. So it will create a flat array of values 1 to 20. Okay, now you have created a flat array. Now how will you generate a array of a different shape you like? So let me take multiple examples and show you everything once for all, so that we can save time. At the same time, I am not missing anything. Let us see one by one. I am having a flat array of 20 elements by using the arange function. So what happens is, when I use this, it is creating the array with these values built into it. Okay, now I can reshape it. Now it is a single dimensional array what you get. Okay, if I write a shape, it will be 20 minus 20 comma it will be. Okay, let me write it, print np flat 20 dot shape. Oh, it is printing everything. Okay, no problem. 20 comma. Okay, so you will get a tuple with a single value, because a single dimensional array with the 20 values in it. Now if I want to reshape it, I can shape it to anything I want. Here, if you see here, 5 4 1. Now you need to remember that the size of this new array that you are generating using the flat array needs to be of same size. Now this has got only 20 elements in them, and when you are writing trying to create a new array with a different dimension, you have to make sure that the total size is not exceeded. Okay, so 5 4 1 exactly same. So 5 into 4 is 20 into 1. So 1 is nothing but another list is made. Okay, another array is made. Okay, this with the same element. So number of elements in this is exactly multiplication of all the values, which is 20. So if I print it, this is what I get. Now you see here, this 1 is actually, this is the total array what you see. Okay, I cannot okay, I can color it. Okay, now you see here how many elements are there. As I told, this is going from here right to left. It is printing 4 rows 1 column, 4 rows 1 column, 5 times they are repeated. So it is printing from the top to bottom. So 4 rows 1 column will be printed 5 times. 1 2 3 4 5. So that is what is getting printed here, which is having all the elements that you had in the original flat array. So it has been rearranged this way. Now can I create, maybe I will remove this for a while. Now can I create one more of different shape, but with its same 20 elements, but in a different structure. So let me say 1 4 5. This also same. Now let me write it as 1 4 5. So I am creating another with the 1 4 5 with the same elements. You can see the difference between that and the previous one. Now you see here 1 4 5, it is printing again from the right to left. Now if you see, this is a 4 rows 5 column, 4 rows 5 column, and then this packing is showing you this one. Okay, whatever is the colored index is showing you the whole thing is again packed into one single array. So this one doesn't actually, when you add one here, it doesn't increase the elements in the array. It increases the dimension of the array. One more dimension is added to the array. So if you just write 4 into 5, 4 comma 5, it will be just a two-dimensional array. I can even create that also. So let me show you that so that you understand the difference between this. Now suppose if I create with only 4 and 5, I can still create because I am using only 20 elements. You see here the difference. This index additional dimension is not there. So effectively, if I add a 1 in anywhere, it doesn't matter whether I am doing it at the end or at the beginning or in the middle, it doesn't increase the number of elements in the array. So remember that the dimensions of all the, this is a three-dimensional array with values 5, 4 and 1. If you want to know the size of this array, you have to just multiply it by all the elements, which is the size. So if I add any number of 1, it doesn't matter. It is not going to increase the number of elements in the array. It is only going to add two more square brackets around it. Okay, remember this. Try it out yourself so that have a better idea about what I mean here. Okay, fine. Now this will help you why I am saying this one, which doesn't make any difference. You will understand it soon when I explain the broadcasting feature. Now let me take this. Okay, I hope any doubt please ask me here. Let me say okay, I want to multiply only the single element of list to a scalar value. Then what we have to do? Okay, that I will tell you. That you can I am going to come to the indexing part where you can access only one. It's like an array index. You can access only one element and multiply and write into it. Okay, element by element also you can do. I am just explaining what you want to do across. Okay, I will explain, no problem, shortly. And then what is this? A of I into B. Okay, if you multiply only one element, it will only multiply that element. Okay, this is if you are writing into A of I, a particular element, then it will do a scalar multiplication of only one element. But if you take a whole array and then try to multiply with a scalar, then you are multiplying all the elements of the array. Very good. Okay, good question. Where I am. Okay, now I copied something, so let me explain here. Now this is what I wanted to tell you. Now I am creating an array with a tuple. Okay, 2, 4, 5. Now, will it create a array like this? Okay, now this reshape. Reshape, I said that it is creating an array of 5 by 4 by 1. Will it create 2 by 4 by 5 or will it create just an element with the values 2, 4, 5? Okay, this is what I showed you in the, okay, let me show you where I showed this. This one I showed you. It is, I put a list there, but I am putting a tuple here. Now, let me print it. What you get here is same element values. It is not creating that many dimensions. Okay, that many dimensions it is not creating. It is the same values. It is considering to be the values that you are passing. So it will create a one-dimensional array with 3 elements. Okay, with the values 2, 4, 5. Here also it will create 4 to 5 when you use array here. Now, let me give another example. This is what I thought I will explain. Okay, this difference you should know what you are using, whether you are using ones and zeros or you are creating a element. Now, when I say tuple with integers are passed to np1s, np0s and np random is also there, they are treated as a shape of the array. Shape of the array, because if you remember, shape of the array is given as a tuple. Okay, even if it's a single dimension array, it just gives you the number of elements in the dimension, comma, leaves it. Okay, that's a shape of the array. So when you say once, you have already mentioned that I am interested in creating an NP array with all the values filled with ones. So the value already mentioned here, what it does is it treats this as not as the actual values, it is treating it as a dimensions, multiple dimensions of array that you want to create with the value all of them filled with ones. So how many elements will be there? It is 2 into 4 into 8, 5. Okay. So 8 into 5, 40. So if I print this, you will get a different 40 elements with ones. Here it defaults assumes that if you don't mention the type, it mention the type, it assumes that you are interested in making a double. Okay, it is a double type. So I put a comment here. Let us not worry about it. Now let me do one more thing. I forgot to write that. Okay, I think I have to put int 8. Will it accept? No, I have to put it under. Okay, so if I don't mention, it will treat it as a double and then it one dot it will create. Otherwise, you can say I am interested in making an array of the same size with filled with int 8. Okay, you are mentioning int 8, that means only 8-bit value, signed integer. It is a signed integer, it is not a u byte. So you can mention the type under as a string and d type is a default value. So it will create that. Okay, if you want to know this is the ones shape, you are mentioning the shape and then d type you can mention, and then order C I will talk about that, what it is. Maybe you can try it out. C style, whether it's a row major or photon style, you can mention. We are anyway going to be using C style, so default is C. D type is none. So when you say 1, it will be filling it with a 1.0. Okay, that means it's a double value. Okay, it internally, if you don't mention the float value, it will be double internally, like what C does. But you can also mention the type. So remember, if I am giving the value to be filled already, then what I mention as a tuple is the dimensions of the array. Whereas if I don't mention the value, I am creating an array, then the tuple is assumed to be the values. Now, this values, it can be either tuple or I can have it as a list also. So if I have it as a list, array 3 maybe. Okay, where is it? Array 3. So it will create a, either you do either this or array 2 or array 3, it is giving you the values of np3. Okay, fine. 4 values, sorry, 3 values. I hope this is clear. Now let me, now what is that thing? I wanted to show you this operation. Suppose if I want to perform an operation, what I want to do, this I need to copy it from here to array 245 and 425. Okay, they both are same type. Okay, even the type here, type is different little bit. Okay, that's why I have moved it here. Now if I want to perform the some operation, an addition of every element, because the sizes of each of them are same, because this is 245 and this is 425, will I be able to perform this job? Because number of elements in each arrays are same, so can I not add them? Okay, just because it is the shape is little different, 245 and 425 are different. You can see that the shapes are array 1 and 2. Where is it? Okay, here 245 is this, Okay, the whole thing, and then 4 to 5 is little rearranged in a different way because it is not little, it is major difference is there. But number of elements are same in both the array. Can I perform this addition? Now, if I try to do that, it says error. Okay. Now, why is it giving error? That's what we are trying to learn today in the next section. Okay, in the coming section. Okay. Now, let me explain this. Why it is not accepting it. Now, let me show you here. The term broadcasting describes how NumPy treats arrays with different shapes during arithmetic operations. Now, when I mention here, I am saying different shapes. Shape means all the dimensions, okay, x comma y comma z. All the dimensions of this come together. We call it as shape of the array. Now, if I am having different shapes, how is it handling is what is broadcasting says. NumPy refers to an array's number of dimensions as its rank. Okay, one more thing you may be aware of it. In NumPy, rank means number of dimensions. Now, if I have this, an array of this type, the rank is 3. Okay. If I have maybe 10 comma 5, an array of dimension 10 means 10 rows, 5 column, and 10 rows. This, the rank is 2. Okay. Number of dimensions here, this is one dimension, this is one dimension. The number of dimensions is called rank in NumPy. Okay, just thought I will mention it. It is often described as an operation. Now I am talking about broadcasting. Broadcasting is often described as an operation between a smaller and a larger array. Now I have an operation to be performed between two different arrays. It could be either this way or it could be operation here. Okay, doesn't matter. The order doesn't matter. The thing is, it is trying to perform operation between two different shapes. The shapes are different. Okay, but size may be same. Okay, we just saw that. So this doesn't necessarily have to be the case. Okay, the smaller and larger need not be the case. It says a broadcasting applies also to arrays of same size, though with different shapes. Okay, now size, as I mentioned, it is a total number of elements. Okay, remember that total number of elements. Now broadcasting rules, whatever I am going to tell you, it also applies to not only different sizes. When I say smaller and larger, the sizes are different. Okay, number of elements here is different from the number of elements here. The size of this array and size of this array are different, size 1 and size 2. But even if the sizes are same, like 245 and 425, the broadcasting rule has to be applied and it might fail. Okay, it is not that if you have same sizes, you can assume that the operation between these shapes can be performed. That's what I'm trying to tell you. This is size is same, this size and this size are same, but this shape and this shape is different. Okay, you cannot say that it is smaller and larger. It is the same size, so you cannot say that these two shapes are smaller and larger. But still, the broadcasting rule says that I cannot perform any operation between these two. In the element wise operation, I cannot perform. So it is not only small and larger array. The broadcasting rule applies for same size with different shapes. Okay, this point you need to understand. So I showed you that this dimension, if I perform plus operation between an array of this shape and array of this shape, it doesn't perform. It doesn't allow. It is wrong. Okay, why it is wrong, I will come to that now. Subject to certain constraints, that is what is actually happening. The smaller array is broadcast across the larger array so that they have a compatible shapes. Now I am talking about this. When I have a smaller array and a capital, some big array, I try to use these values, whatever values, values I have. This array I broadcast it. Okay, I mean the same value broadcast means you know that same value is sent across. So the same value is sent across. So 2 may be broadcast multiple times, 3 may be multiple times, 5, the 4, 5, so multiple places. So I make it as if it is same as this array. And then I do a element by element operation. Whatever you want to do operation, that will be performed. Now, this is broadcasting is allowed. It will allow to perform that broadcast only between compatible shapes. Okay. It is not that all the larger and smaller arrays can be accepted for performing this job, the broadcasting. Okay. Now, what is the compatible shape? Now, let us try to understand. Before that, broadcasting provides a means of vectorizing array operations so that looping occurs in C instead of Python. Now, what I mean by that, when you have a compatible shapes, which is of smaller and larger sizes, okay, then we perform some, we do some, apply some rules to find out whether they are compatible shape or not. If it is a compatible shape, broadcasting is done and it is made equal to the sizes, the larger size, and then the operation is performed. To perform that, a vectorization means the same value being sent, making it as a vector. Every scalar is made into a vector. So an example what I showed you, 2, 4, 5 array with a multiply by some value 2, we are doing a vectorization here. This scalar value is vectorized as 2.0, 2.0, comma 2.0, and then we perform the job, okay, on each element. So vectorization is performed on this, and then looping occurs in C, not in Python. Okay, so it performs much efficient in NumPy. Now it does this without making needless copies, I mentioned already, so that efficiency is preserved. It's only conceptual. The copying is a conceptual one. It doesn't actually perform the copying internally. Now, NumPy operations are usually done on pairs of arrays on element by element basis, for which both arrays need to be of same shape. Okay, so if you want to perform by element by element, they need to be same shape. If I need to make it same shape, that means a smaller one is made equal to the bigger one, and then the operation is performed. But not all the small and this larger shapes are compatible. So some things are compatible, then they can make it into the larger one and then perform the job. That's what I'm saying. They need to be compatible shapes. When they are different, they need to be compatible shape, and even when they are same, they need to be compatible. Otherwise, it will not be performing the operation. Now, let me give an example. Now, suppose if you have an array of this, it is very easy. You can say that it will be multiplying the same A into B. Now, with the broadcasting, we perform the same job, which I mentioned already. We make it into the same one-dimensional array and then perform the job. Now, I am going to define the rule now. This is what is very important. I will explain it bit by bit. When you are performing element-wise operations on arrays, they are only element-wise operations on arrays are only valid when the array's shapes are either equal or compatible. Even equal, not all of them are possible. I mentioned it to you. 2, 4, 5 and 5, 4, 2 are different. The shapes are different. Okay. If the shapes are same, no problem. Suppose, see here, 2, 4, 5 an array, another is 2, 4, 5. Only when the shapes, the same ordering is maintained, the dimensions of each array. What I mean by dimension, each of them are dimension, and this 2 means number of elements in the each dimension. So this is this dimension has 2 elements, this has got 4 elements, this has got 5 elements. So totally there are 840 sides. Now these two shapes are same only when the ordering is also same. Okay, or if they are different, they need to be of compatible shapes. Either size may be same or size may be different, doesn't matter, larger or smaller, but they need to be of compatible shape. Now I am going to explain what is a compatible shape I mean. Now the equal shapes case is trivial. It includes the stretched array from scalar value also. Now when I say equal shape, it also includes the scalar value. Example. Now if I say some size as 2, 4, 5, I can operate with the another size 2, 4, 5, or I can also operate with one scalar value. Okay, then what happens? This scalar value is constructed as the shape 2 rows 4 column 5 times. So with the populated with all the values with the same 2.0, and then I can perform the job. So a scalar value, I can do it with any shape. Okay, this can be any shape. I can multiply it with a scalar value. All the elements will be multiplied because there is no ambiguity. The same value has to be performed on all the elements of the array. So a scalar value can be changed into any shape. Okay, but if they are different shape, then they need to be compatible. What does compatible mean? To determine, okay, if two shapes are compatible, NumPy compares their dimensions starting with the trailing ones and working its way backwards. Now is a very important thing. I have an array with how many dimensions are there? 4 dimensions are there. Each of them having how many elements? This is 4 element, 5 element, 7 element, 2 element. Now total size is 4 into 5 into 7 into 2. Okay. So if I try to print this value, I can create any dimension like this huge number. It will be printing so many lines. So your console buffer length, that line, number of lines, you need to increase it if you want to see all output coming. That's why I explained you why you should be worried about the console buffer. Okay, fine. Now let us look at the broadcasting rule definition. What is this broadcasting rule means? Suppose you are given an array of this size. Okay, 4, 5, 7, 2 dimensions. There are 4 dimensions with the values of 4, 5, 7, 2. I am having, let me say this is a larger array I have. I want to perform some operation on a smaller array. Okay, something. Or maybe bigger than this I want to perform. Now, it has got 2 arrays now to compare against. When it is trying to find out whether can I perform a job between these 2 arrays, whether they are compatible or not, whether can I expand a smaller of these 2 dimensions into such that I can perform the operation in an unambiguous way. Unambiguous means I do not have 2 different ways of expanding the smaller array into a bigger array to perform the job, element by element operation. So there should be a very unambiguous way of expanding this smaller array. Suppose if I call this as smaller and this is larger, I should be in a position to expand this in a unambiguous way to a larger array so that I can perform the job. Then only I can call them as compatible type. Now, how do I do it? Comparison. The NumPy does it by trailing end. Okay, if this is the array defined, it is starting with a trailing end. Now, what is trailing and leading? I am sure you guys will be knowing, but just to name it properly, leading zeros are these zeros. Trailing zeros are these zeros. Those trailing means something which is coming to the end, trailer, okay, or the end of the thing. So when I am starting the comparison of 2 arrays, I have another some x, y, some dimension like this. Suppose this is a smaller dimension. This is the larger dimension. Now NumPy is trying to identify whether this is some array. Can I perform some operation between these 2 arrays or not? Then it should know whether these 2 arrays are compatible or not, because the shapes are different. Okay, sizes may be different, same, because x into y into z may be equal to 4 into 5 into 7 into 2. Size may be same, may not be same, but still it is not guaranteed that this operation can be performed. So I need to see whether they are compatible or not. Now I am explaining you how do I compare whether 2 dimensions arrays, either whether shape is same or not, doesn't matter. Okay, size is same or not, doesn't matter, but shapes are different. So I am trying to compare. If shapes are same, that means you are having same 4, 5, 7, 2. Okay, then I don't have to do any compatibility check. It is true, I can do it. Or if you have a scalar value, I want to perform a scalar value, only one value, that is also no problem. I don't need to worry about it. I will not do a compatibility check for a scalar value. I will not do a compatibility check for the same dimension, the same shape. If I have the same shape, I can perform element by element operation, but I'll do a compatible check only when the shapes are different. Size could be same or different. Okay, size is different from shape. So how do I compare the shapes, whether they are compatible or not? So it is going to compare dimension by dimension starting from the leading side. Now let me explain. Now this rule will come up now. From the trailing end means from the rightmost dimension, which is 2 here. Okay, read out this properly. If two dimensions are equal, that means, let me explain it clearly. Suppose this is the array 4, 5, 7, 2. I am going to compare the dimensions of, this is one array 1, I am having array 2. Okay, I am comparing, suppose some value 2 is there. I am starting from the trailing edge. Now two dimensions are same. The two dimensions are equal, or if one of them equals to 1. That means if I have an array 7, 2 and this happens to be 1, okay, 5, something like that. Okay, if this happens to be 1, okay, I am comparing it from here. Either it is same. If it is same, I will declare that okay, this dimension I have no problem, they are compatible. So I will come to the next dimension and try to compare these two. Okay, if they are same, I will come to the next one. Or if one of them is 1, okay, if this is 2 and this is 1, I am fine. If one of them is just 1, then also no issues. Okay, so that's what it says, this line. If two dimensions are equal, or if one of them equals to 1, the comparison continues. That means I will start comparing the next two dimensions if it is there. Okay, otherwise, if suppose they are not falling under this equal category, or one of them is not equal to 1, then I will say it is not possible for me to do the job operation between these two arrays. It will generate a value error saying something like operands could not be broadcast together with the shapes so and so. So what I am saying is it will keep coming here from trailing edge, start comparing the dimensions one by one, because when I say one by one means, do not assume that if I have 4 dimensions here, I will also have 4 dimensions here. I may have less or more. That means the arrays that I am comparing, the dimensions need not be same. One can be a 4-dimensional array, some can be a single dimensional array. So when it is happening like this, if I am trying to compare two arrays with the one is 4-dimensional and another one is 2-dimensional, I will start comparing from the right and then see whether it is either equal or one of them is 1. Now if it is equal, that means it's a single dimensional array with first this dimension is 2, elements are 2. I declare them is okay. Then I come next. Now what if I don't have anything at all? Suppose there is, this array ends there. Now what do I compare with? Now it is going to assume that all the missing things are 1s. Okay, as I mentioned to you, if I put 1, I am not adding any new element to this array. The size of this array still remains 2, but the dimensions are little bit different now. I am trying to do a compatibility check whether can I perform an operation between these two arrays. So I am going to expand this to equal to this number of dimensions, but I will fill it with the empty ones as 1s. So now I perform the comparison. After filling it up with 1, I compare. One of them is 1. Okay, if either they are equal or one of them is 1, that satisfies now. Then I come here. Oh, this is one of them is 1. Okay, this also satisfies. This, yes. Now this is a compatible type. That means if I need to perform a job between an array of this size and an array of a single dimensional array with a 2 element in it, it is a compatible type. Broadcasting feature expands it with 1s wherever the dimensions are missing and then starts from the right to left and decides the compatibility of these two types. Now, what will be the result? What is the dimension of the result? The dimension of the result of performing this job, whatever may be the plus or minus, the values will be decided by the operation you perform, but the dimensions is going to be decided by the dimensions of one of the arrays. Now, when you want to know the dimension, it is very simple. Compare the dimensions of this. After the expansion is done, compare the dimensions. Whichever is the larger, you choose that. This is 2. If it is same, you pick that same one. Here 7 and 1, 7. This is 5. This is 4. So your result will be of 4, 5, 7, 2. And you verified that it is a compatible type, and then you also know what is the size, what is the shape of the result. It is going to be the larger of the two dimensions, and the values of the elements is decided by the operation you perform, and then of course values in this array and values in this array. Now you may wonder, what is this one? It is a broadcast of this done. Okay, I will show you with the example, then you will understand it. Okay, I hope this is clear. So far what I explained. Okay, when one of the shapes run out of dimension, that's what I said. When 4, 5, 7, 2 and you are comparing with the 2, it is running out of the dimension. When one of them is running out of the dimension, because it has less dimensions than the other shape, NumPy will use 1 in the comparison process until the other shape dimensions run out of as well. So this dimension also runs out. Till then it will assume that it is 1 is there. Okay, so it will perform the comparison, but it will keep comparing it with 1 and then say, oh, okay, fine, I have done. Why is it doing till the end? Because it has to know the dimension of the result. So dimension of the result will be the dimension of the larger array. Okay, so it will always be the dimension of the larger array. Now, once NumPy determines that two shapes are compatible, the shape of the result is simply the maximum of the two shapes sizes in each dimension. So when I perform a comparison, I will come up with the result which is the larger of the two dimensions. I hope this is clear. So far what I explained, at least the process is clear. If not, the actually what is happening. Okay, let me see whether there are any questions so far. Okay, no questions. Looks like everything is understood. Okay, now my job is to explain you with the example. Okay, now I am going to take okay, what about guys, can I take some 10-15 minutes more today, or what is this? Today you have I will finish up only the
Yes, sir, you can take.
Okay, fine. I will only finish up the what is it called, broadcasting, and then stop. Indexing I will take it up later. Okay, because I don't want to I hope this is clear so far. Now let me come here. Now you look at this result again. Okay, let me explain with this example why it is not working. Okay, then you will understand it better, whether it is following the rules or not. Now I said dimension, it is 2, 4, 5. Another one dimension is 4, 2, 5. I said it has to compare from the trailing edge. Fine. Is the dimension same? Yes. So it will do the next comparison. Now, is the dimension same? No. Dimensions are not the same one. 4 and 2. Is one of them is 1? One of them is 1? No. Both are non-1 values. One is 4 and another one is 2. It doesn't matter which is bigger or which is larger, because you may have 2 here and 4 there. It doesn't matter. As long as they are of different sizes, different values, this is not a compatible type. So the reason that this operation failed is because of these two not being same. Now I will prove it to you that if I make this as 4, this is also 4, then also it will fail, because the reason is this, it has failed here. Even if they are same, it doesn't matter. Beyond that, if it is same also doesn't matter. If the shapes are different, it will be failing. So let us give an example of, only I will construct that array just to prove it. You can also check it out, but it is worthwhile to show you that now what is happening. I said that this is different. I will make it this same. Okay. Even then, it should fail. Okay. The reason is, first of all, size itself is not same here, but that is not the criteria. It applies the rule to perform this job. Okay. So array, I don't know why I put capital there. Okay, fine. I'm not following the convention. 4 to 5. It doesn't matter what operation I perform. Sorry, 4, 4, 5. Now, see here the interpreter does not, sorry, the whatever compiler or syntax calculator thing, it doesn't show you any error. But when I perform it, it gives you the error that they are not compatible shape. So the rule that I applied is not working out here because these shapes are different. They are not, one of them is not one. Okay, fine. I hope this is clear. Then the rest of it will be very simple. So I will, before I will show you some examples and then we'll go into quiz. Okay, so that things will get registered in your brain forever. Okay, rule definition I already explained. Now I am going to show you example. See here. What is it? Is it going to be same? Yeah, 4 comma 3. This is 3. I do this. Very simple, like a computer you can do, but I want you to understand what you are doing also. 3 is same. Now this element is not there, so I will replace it with 1. So 4 and 1 is okay. And the result is same as the larger of the two element. So this will be the dimension of what I get the result. So that is what is. This is a valid value, no issues. Okay. Now I will not explain everywhere. I'm sure you can mentally construct it. It's constructed here. So 3, 3, 1, 4, 1, 5. I am happy. It's working out fine. 5, 4, 3 will be the result. What about this guy? This also same. 1, 1, 5, 5, 4, 3. And now what is this? Okay. Is it the same? Now what is happening is the first element itself, there is a problem. 5 and 3 is different. So even though this is okay, this is wrong. So it will fail. If I try to do a comparison, perform some operation on these two arrays, remember one thing, when I am actually performing the job, I am having the array of this type only. I am not defining an array of this type. It is internally done by the NumPy. Remember that. I am not doing it like this. I will be defining an array of this type and then try to perform the job. But I am trying to explain you why it is failing and why is it giving a value error. Which particular dimension is the cause. Okay. Here the first dimension is itself from the right trailing edge is this dimension itself is wrong. Okay. Now what about this? I have a 4D array and 3D array. Can you tell me whether, just mentally compare and tell me whether this will be okay or not and what will be the result? Okay, just quickly do it on mental comparison and it will be this one 8765. So it is valid. Result is valid. 4D array. What about these two? Very simple. I am sure you will know. This is also fine. What about these two guys? Fine. Okay. What about this? Fantastic. There no problem. You will have this result. And what about this? It's also very good. No issues. What about this? No issues. Now I am going to give a quiz. Okay. I will give some 2 minutes. Okay, I will give you 5 minutes. Please see which one of them are valid, which one of them will result in value error. So see here, you have to just 3, 3, 4, 4, 5, 5, everything is matching. I can replace it with 1, so no issues. The result will be of this shape. 1, 3, 4, 1, 5, 5, very good, no issues. What about this? 2, 3, invalid, that's all gone. What about this? 4, 4 is fine, but 3, 2 is invalid, gone. What about this? 1, 4 is fine, 2, 2 is same, 3, 1 is fine, 4, 4 is same, 2, 1 I will add with 1. So this is valid. What about this? 3, 3 is okay, but and then 2, 1, that is also okay because one of them is 1. 4, 4, no problem, same value. 3, 1, one of them is 1, so no issues. But the last one is 2, 3. So you may make a mistake here. I hope you are not made it. So 2, 3 is different shape, different sizes. It's not one of them is 1, so it is a value. So this is what is going to happen. So I hope.
Sir,
Yeah.
sir, can you explain the third one again?
Okay. Which one? This one?
Third one.
Okay. So here 3, 6, 3, 2 is a dimension and 1, 1. Now it compares from here, and then this 3 and 2 are different. They are not one of the same value. It is not like 3, 3 or 3, 1. Now let me logically explain why it is not possible to perform the job. Okay, maybe that I missed it so far. I have not done it. Only explain the rule. Okay, now is it possible now? I want to do it. Now forget about this 3 and 6. Maybe the simplest thing is I can make it replace it with 1, 1 to just explain. Okay, because for a simplicity sake, suppose if I have a, okay, 1, 1 is also different. So let me isolate, I'll give you some example. 2, 2, suppose, okay, I can visualize it, and 3, this is one array, and then another array is just a 2-dimension array. Now 2 elements in this single dimension array, and then it's a 3-dimensional array with a 2 element here, 2 element here, 3 element here. Now how will it look? It will be like, if I construct it, 2 rows 2 column, so x x x x, no, 2 rows 2 column, this is what is this, into 3 I need to replace it with this 3 times. Now I have a single dimension array with 2 values, so y, y. Okay, now I want to perform a job, suppose addition. How do I, this is 2 values are there. Okay, where is my pen? This is y1, y2. Now I need to perform some operation using this 2-dimensional array on this. Okay, because this is 3, I have 3 copies of this. Now for a moment assume that this was not 3, okay, it was 2, suppose. Now in that case I will not have this at all. This array, extra array, will not be there if there are only 2. Then if I am given another array which is having only 2 elements, y1 and y2, it's a single dimension array, but it's a 2 element having y1 and y2. Can I perform this job? My broadcasting rule would have said that, yeah, this is the same number, no problem, you can perform. And then I will replace it with 1, and then it will declare that, okay, it's compatible type. Now why is it saying it's compatible type? Because I have only 2 elements. I lose my pen. I have only 2 elements. I can now decide that I will apply this y1 on all these elements. I will apply this y2 value on all these elements and do a scalar operation of whatever I have want to do. Then I can get the result. Now the result what I get will be the same size as this. Okay, 2 by 2. Okay, I'm sorry. Yeah, correct. So I will get the same size as the original size because I will do the multiplication of every element and I will get the same size as the original size. But since there are 3 there, now I have a problem. Now this is also there. How do I decide now? How do I apply this y1? You cannot say that, okay, I will apply this y1 on this, and this, like this I will apply y1. If you say that, I may question you, why are you doing this way? Why not you do this way? Why not you do this? There are 2 ways I can perform this job. This y1 and y2 I can multiply by column wise or row wise. I have a flexibility there whether I can do it one of this. Okay, so there won't be any uniform way of performing the job and unambiguous way of performing the job. That's why they are not compatible. Okay, these two are not compatible for the reason when they are not of the same say value, they get into this kind of compatibility issue. Whereas if I have the same shape, then no issues. Okay. Now suppose now 3, 6, 3 and 3. Suppose if I have, they are of same shape. Now can I perform? They are compatible. Now how do I say it is compatible? This is let me call it as 2 only. Okay, for writing it proper. So 2, 2, 2, 2, 2, 2, and 3 such arrays are there. Actually, I need to, okay, one is 2, 2, 2. One more I have to do 3, 3. Now another array I have y1, y2, y3. Now there is no ambiguity. I can multiply y1 here, all y2 here, and y3 here. So that is why it is says that this is not compatible. Is it clear?
Yes, sir. Sir, what is the difference between 1, 2 and 2, this?
Sorry, please come again.
1, 2.
Okay.
And 2, just 2,
Oh, 2, comma. Okay.
Yeah.
First of all, this is a tuple. Okay, this is a tuple. Both are tuple. Now 1, 2 means two-dimensional array, and the size of each is same. 2 into 1 equal to 2. Two elements are only there. This is a single dimensional array with the size as 1 or size as 2. Okay, two elements are there. Now the difference is, now you have, if I go from here, x some 2 element, this, and then there is 1. It is actually an array inside an array. Okay, with the one element there. It's not only one this. It is captured as another array. This is a single entry. Okay, this whole array is sitting like an element in the array. It is like, if I say, it is equivalent to a, suppose if I am giving you a gift and then saying that your gift is there like this. Okay, your gift is here. That means what? You have to open 3 boxes to reach your gift. This is different from, I say your gift is like this. You have to open only 2 boxes to get it. So even though the number of element is same in both arrays, they are constructively, in terms of construction wise, they are different. Okay, so if I want to explain, got it right? So okay, fine. I hope this is clear. I suddenly got the gift idea. I will give you a gift, don't worry. Okay guys, so now I am going to not take more time by doing something, running. Okay, what I actually had prepared was just to show you exactly the quiz values. Okay, that's why I don't need to waste time on explaining this. I could have given as a homework, but I want to make sure that I also verify it. So you can try it out yourself. So the same quiz, whatever I gave you, I implemented it. Okay, and then proving it to you that they are, what I showed in the slide is same as what is happening. You have to uncomment them to know whether they are giving error or not. So wherever number 3, number 4, wherever this value number 1, number 2, I mentioned the code here. Okay, mentioned it in code how to verify it.